So today I'm going to explain the covering problems. So the covering problem is the method in selecting facilities to be added in the current facility that has been installed. But in this case, we want to add multiple facilities, so we can use this method as a solution. And the method itself covers two different functions, just like total cover problems. So in the total cover problems is determining the minimum numbers of the facility required to cover a set of existing facility. So it means that all of the existing facility must be covered by by the new facility. And for partial cover problem, it means they only cover a half or maybe in a certain numbers of statements. So in this case, we want to determine the location of specific number of new facilities to maximize the number of existing facilities covered by the specific number of new facilities. So it means that the maximum number of the existing facility must be covered by the new facility. So let's take a look to the practice problem, which has a binary information in here. So let's say I have 10 stores, and this store will be served by the DC, which is distribution centers. So the DC should be built in order to serve my stores. I have 10 stores and I want to build a huge DC to cover the needs of my stores. So by using the information, I can see that each DC has different destination stores. For example, DC number 1, they only serves stores number 1. So 1 represents that they serves, and 0 means they doesn't serve the stores. So number 1, number 2, number 3, number 8, and store number 9. So they only cover maybe the rest of the store. So there's still a remaining store that are not being served with the DC. So let's take a look another DC. So by using this information, we can see that another DC will cover the remaining store that has not been set. So by using the covering problems, I can produce a solutions that we only build several DC instead of build all the DC. So build 10 DC at the same time is very costly and it's very expensive. It needs a huge amount of project that should be carried on. So in covering problems, the result is just building maybe a few DC that will cover all my stores. So that's the aims of covering problems. So let's begin the calculations. The first thing you have to do is just like do some trial errors. Since you know that binary one represents the DC that should be filled or DC that has not been filled by store that has not been built by the distribution centers. So now let's start with the initial one. So I put distribution number 1 as my first iterations. So DC number 1 serves store number 1, 2. Sorry, you can draw a very accurate line. So it helps you to reduce an error. So it serves stores number 1, 2, 3, 8, and 9. And you know that the other DC means there will be substitutes with the first DC. Let's say that DC number 1 will fulfill the needs of stores number 1, 2, 3, 8, and 9. Now let's take a look. Take a look again. If I choose store number DC number 2, they only serve stores number 7. It means we still have to build another DC. Since the end of covering problem is just minimizing the minimizing and building projects and minimizing establishing the buildings of distribution centers, so we can see another option just like maybe distribution number 6, because DC number 6 can serve store number 4, 5, 6, 7, and 10. It means, on the other hand, all my store had been served by the proposed distribution centers. So in this case, the result of covering problem in this case is just like building 2 DC, which is DC number 1 and 6 only, instead of build all the new DC at the same time, which is 10.